on days when we are doing synthetic, I am encountering, because, I'm teaching other classes as well, Algebra 2, and then writing tests and things after school, working with thousands of numbers every day. So I'm not perfect. If I make a mistake on one, you guys let me know. Um, doesn't happen a lot, but it occasionally happens. So don't be afraid to stop me and say, oh, Cedarholm, that should have been an 8 in that position. So let's see, where were we? All right, so before we get going on this example, I sent out an update yesterday in the afternoon to let you know that we still had one person who hasn't taken the 2-1 and 2-3 tests yet. So that means I can't open up the retake material to everybody, because then the person who hasn't taken the test yet is going to see how to do the test, because that's what I use for the retake videos. So if you are a person that's interested in the retakes for the 2-1 to 2-3 test, just send me a quick email, or at the end of class, you could unmute yourself and say something, and I'll put you on the list, because I can assign you that retake, and that way you can get in, but the person who hasn't taken the test yet can't. So that's the way we'll take care of that. Like I said, just send me a quick email saying I'm interested in the retake, and I'll open that up to you. All right, so as we go through that big long list of objectives that we had, it all comes down to we need to be able to find all the zeros for any polynomial. So there are a lot of steps involved in these as we try to figure out, well, how many are there? Are there some possibles that we can try? What can we do here? And have your graphing calculator handy today. We're going to use it for one problem, but you're going to want it when we get to that point. So extra examples A through D, because we haven't seen every case. Use synthetic division to find the simplified exact zeros of each of the following. Use completing the square, and we're going to stop there, because as I told you, the derivation of the quadratic formula takes calculus. And if we haven't seen how something is derived, and if we can't prove it, we really shouldn't be using it. So we will use completing the square on a couple of these today as we go through. So it says f of x equals 2x cubed plus x squared minus 41x plus 20. And my first thought was, well, there's supposed to be 3 zeros. This is a degree 3 polynomial. It should have 3 of them. And then I notice, oh, look at that, they gave me one. How nice of them. Now, this is a new notation for us to show a 0. Yesterday, we were just writing it as ordered pairs, something 0. And today, they're showing us, well, here's a new notation. And when that happens in a problem, you really should, best practice is to follow the new notation. So we should be using that as we go through. Now, if they're handing me this one, that means I can skip that step of grabbing the graphing calculator if this thing isn't factorable by grouping. And if you take a quick look at it, you're going to see this would not be factorable by grouping. So that means we can start right away with the 1/2. 3, 2, 1, 0, they're all there. And I want you to go ahead and do the synthetic, and then I'm going to call on somebody to tell me what they got for their last line of info on this one. Now, nobody has their camera on, so I'm just going to have to take a guess and hope that I gave you enough time to finish up that synthetic on that last line there. O and R, what'd you get for those last numbers? Please unmute yourself and tell me what you had.
2, 2, negative 40, and 0.
Beautiful. Now, we expected the 0. It told us if you put 1/2 into this thing, you're supposed to get a 0. But we need the other numbers because we know that there's 2 more of these out there. So now we have to think, okay, what do I have left? And remember that this is remainder, constant, x, and x squared. So we have 2x squared plus 2x minus 40 equals 0. And now, one of the rare times, because it seems like I run through these all the time and we can't do step 1, factor out a greatest common monomial factor. This one actually has one. We can take a 2 out of it. And then our hope is that this is going to be something that's factorable, so we can find those 2 remaining zeros by showing algebra work. So go ahead and factor that if it's possible. I'm going to call on somebody to tell me how that was factored. Thomas, you got that one factored? Can you unmute and tell us what you had?
I got 2 times x plus 5, x minus 4.
Beautiful. There it is. So our other zeros are -5 and 4. Now, here's where you impress the person that's writing this test. And we will take, if you write down 1/2 0, -5 0, and 4 0. That's an appropriate answer. However, best practice would be, because this problem was written with this new notation, we should use that new notation and say, all right, they gave me this one, and I found -5 and 4. And it's kind of an inventory at the end. Did I find everything I was supposed to find? It was degree 3, should have 3 zeros. Bam. There, I've got them all. And you have them somewhere that it's very easy to see, oh, look, there's all their answers. But again, all of the points come from the work. You know, each step in these is going to be worth a point. So there's quite a lot there. And this is why we get to a point in pre-calculus where we only have 6 or 8 problems on a test. And that's because each one is so detailed that it takes a while. All right, let's keep cruising. And this one says f of x equals x to the 4th plus 3x cubed minus 16x squared minus 27x plus 63. And look at that. They're giving us 2 of them this time. We have f of -3 equals 0 and f of 3 equals 0. So I start with the fact that it is a degree 4 polynomial. And I notice they're doing exactly what I need here. If there's 4 of these and I can't factor it, I need this to get down to a quadratic, because quadratics we can solve by completing the square if we have to. But look at that, they gave us 2. So if it's degree 4 and I already have 2 of them, they're going to make it a quadratic for me, and I'll be able to find those other 2 algebraically. So let's go ahead and use the -3 first. And 4, 3, 2, 1, 0, they're all there. And again, I'm going to give you a chance to go ahead and do the synthetic on that, and then I will call on somebody to tell me what they have as that last line. This one had a little bigger numbers, so I'm trying to give you a little bigger time, little bit more time on this one. Andy, do you have that last row of numbers for us, please?
1, 0, -16, 21, and 0.
1, 0, -16, 21, and 0. Beautiful. So now, because that worked, I'm not going to start over. Remember, I'm trying to work this down to a quadratic. I'm going to use the fact that they also told me that 3 is going to work. So let's do that again. Go ahead and do your synthetic, and I'll call on somebody to give me their last line. Hope I gave you enough time. A little bit less math to do with each step in the synthetic. So, Jonah, what'd you get for that last line? Oh, don't forget to unmute yourself.
1, 3, negative 7, and 0.
Beautiful. 1, 3, negative 7, and 0. So now we definitely have this down to a quadratic. Remainder remainder constant, I'm getting ahead of myself there, x and x squared. So now it's x squared plus 3x minus 7 equals 0. And we would, of course, want to try and factor this. But there's no greatest common monomial factor. It's not a perfect square trinomial. And we would need two numbers that multiply to negative 7 and add to 3. And we quickly realize that's not happening. Now, that would mean we have to have a backup plan. And as I said, our backup plan is completing the square. So let's move that 7 over. And let's use that process of completing the square. Doggone it. I keep moving it up, and then I remember that that's where the glare is for all of you. I have to try to write lower here. So here's our b. We divide it by 2 and we square it. And 3 squared is 9, and 2 squared is 4. So the good news is we just made a perfect square trinomial, and it is x plus, and we know what we squared. We had to square 3 halves. On the other side, either do it in your head or use your calculator if you want to, but we need that fraction, and we need it as an improper fraction. So 7 in fourths would be 28 fourths. So 28 fourths plus 9 fourths would be 37 fourths. And now we've set this up so that we can take the square roots. So square root of both sides, the quantity x plus 3 halves, actually I'll drop the parentheses now that we've undid our squaring, equals plus or minus. Whenever we physically write that square root symbol down, we need that plus or minus piece. And then we would separate these two, because 37 fourths, that doesn't make sense, thinking what's the square root of 37 fourths? But if we think about it as the square root of 37 over the square root of 4, we realize that's going to be really helpful, because then we won't have a radical in the denominator anymore. That will be a 2. And finally, we need to subtract our 3 halves. And then you decide at the end, should I be writing this as negative 3 halves plus the square root of 37 halves 0 as an ordered pair? But a best practice, they gave us that notation. Go off to the side. Write the ones that you were given. And then remember that we had two new ones here. F of negative 3 halves plus the square root of 37 over 2, and f of negative 3 halves minus the square root of 37 over 2. And I also would take that if you just wrote it in 1 and put the plus or minus in between it. That would be totally fine. But like I said, it's a good stopping point at the end inventory. Did I find them all? And this was a degree 4 polynomial, and we needed to have all of them. So thinking in terms of steps, this problem would be worth more because you had to do the completing the square process instead of just factoring to find those last zeros. And that's a little tougher, has a few more steps. So again, each one of these has a lot of work to it. Alrighty, so now we're at the top of the next page, and it says f of x equals 10 plus 5x minus x cubed minus 7x squared plus x to the 4th, and they're giving us a 0 of the square root of 5. But the first thing you notice is, this isn't written in standard form. So we have to put it in standard form. And that will be x to the 4th minus x to the 3rd minus 7x squared plus 5x plus 10. All right, it's a degree 4 polynomial. So if we can get 2 of these zeros, we'll be down to a quadratic and we can definitely find the other 2. Well, they gave me 1, so I suppose I'll have to start with that. But it's a strange one. It's the square root of 5. So when you have irrational roots, which is what this is, the square root of 5 is not going to be written as some nice fraction. It's a decimal that doesn't have a pattern, just keeps going forever. So what you want to do is spread things out a little bit more, because we're not just dealing with integers here. We're also going to have some radicals in our answers. 4, 3, 2, 1, 0, they're all there. And that said, I hope I spread mine out enough, but you'll still be able to read everything that I have on there. All right, so here's what I have to do. I go through the same steps that I do with synthetic, but I have to remember that integers can be added and subtracted to other integers, and radicals can only be added or subtracted to like radicals. So I bring down the 1. 1 times the square root of 5 is the square root of 5. But again, I cannot combine -1 and the square root of 5 other than to say this is going to be -1 plus the square root of 5. That's the best I can do. And then I have to do some work. I need to take the square root of 5 times the quantity -1 plus the square root of 5. And this is where you should find a spot either in the margin to the left or the right and show the work for doing this math. Because many times if students try to do the whole thing in their head, they end up losing something. And that's not what this is about anyway. We're supposed to show all of our work. So square root of 5 times -1 would be negative square root of 5. Square root of 5 times a positive square root of 5 would be plus the square root of 25, which we know is 5. So now I'm going to reverse that because I put the integer in the front. 5 minus the square root of 5. And I add. So -7 plus 5 is going to give me -2 minus the square root of 5. Now I have to start again. So I'm coming over here and showing my work for distributing that square root of 5. -2 square roots of 5 minus the square root of 5 times the square root of 5 is the square root of 25, which is 5. So this is going to be -5 minus 2 square roots of 5. Now something good happens. 5 minus 5 is 0. And I get -2 square roots of 5. So my hope is when I take square root of 5 times -2 square roots of 5, I get -10, because that's what's supposed to happen. So off to the side again. Square root of 5 times -2 square roots of 5. That will be -2 times 1, which is -2. Square root of 5 times the square root of 5 is the square root of 25, which is 5. Hey, look, there's our -10. Woohoo! And there's our 0. And then for just a split second, we're a little distressed because this is a cubic. And it's a cubic with all kinds of horrible radicals. So there must have been something we missed up here, because we can't stop there. We need to get this down to a quadratic. This is a challenge question. Does anybody realize what we missed in this that's supposed to continue to help us? Too early in the morning for a challenge question, huh? Here's what we missed. Do you remember in the last problem when we had to take the square root, how we had to write down the plus or minus symbol? Yeah, whenever you have irrational zeros, they come in pairs. So if f of -5 equals 0, we're supposed to realize, oh, that means negative square root of 5 is also going to be a 0. So that will be what I have to do synthetic with again. Now the good news is The second time through with irrational zeros, the synthetic is not as bad. You probably won't have to show all this work. The first time through, there is a lot of work to keeping track of everything. But the second time through, you might not have to show a whole lot of work. So you bring down the 1, you multiply, and look at that. Square root of 5 minus the square root of 5 is going to drop right out. We get negative 1. Negative 1 times negative square root of 5 is a positive square root of 5. Well, look at that. It happened again. Negative square root of 5 and positive square root of 5 dropped right out. You get negative 2. Negative 2 times negative square root of 5 will be 2 square roots of 5. And that is beautiful. So notice how now, no more radicals. This is something we can do here. So remainder, constant x squared. And our hope is always that this is going to be factorable. So that's the first thing we try. Doesn't have a greatest common monomial factor. Numbers are pretty small here. So we're looking for two numbers that multiply to negative 2 and add to negative 1, and I think we have a pair of those. So factor that. Natalie Murphy, can you tell me what you had for your factors? Unmute yourself real quick.
X plus 1 and x minus 2.
Yep. Yep, there's our multiply to negative 2 and add to negative 1. So our other zeros are nice rational zeros. We've got a negative 1 and a 2. But I have to make sure that I show that I understood that these are the zeros when we graph this. And I have to make sure that I'm listing that negative square root of 5. So off to the side we go. There's the one they gave us. That's the one we reasoned to, and again, we had to show that that actually worked by synthetic. You have to verify that. And then we got negative 1 and 2. So f of negative 1 equals 0, and f of 2 equals 0. And I remember way back when we started this, it was a degree 4 polynomial, and I have all 4 of them. So there they are. So the irrational zeros, they take a little longer. You have to be a little more careful as you're doing your synthetic that first time through. The second time should always be easier. If it's not, you need to worry that maybe you messed up on that last line. So be careful with that. Uh-oh, why is this giving me a message about Adobe Flash? All right, hopefully that didn't mess up anything for any of you. D says f of x equals x to the 4th minus 5x squared minus 2x to the 3rd plus 8x plus 4. So they're not in order. That'll be the first thing to take care of. We need these in standard form so that we can do our synthetic properly. And then I look at the 0 they're giving me. Yikes. Okay, well, it's a degree 4 polynomial. And right away, I'm saying they're not going to do this to me again. I know that if 1 minus the square root of 2 is there, then 1 plus the square root of 2 has to be there too. But again, we have to verify all that. And definitely with this one, you want to space things out. This is not just a radical this time. It also has an integer portion, so we need some space. Again, I always write so big that I'm worried I'm not going to have enough space to do everything here. All right, so let's get started. We know this is going to be the toughest one. The very first one is the hardest one. So you bring the 1 down. You multiply by 1, you get 1 minus the square root of 2. So far, not so bad. And then you realize, okay, well, I'm going to have an integer portion and a radical portion here. Negative 2 plus 1 is negative 1 minus the square root of 2. Got to have that workspace. So I have to multiply this. And it looks a lot like a binomial times a binomial. And whenever we have a binomial times a binomial, it doesn't matter if they're nice numbers in there or variables or whatever, we use FOIL to get that done. So first times first will be -1. Outside times outside will be a negative square root of 2. Inside times inside will be a positive square root of 2. Those two cancel out. So I'm not going to even write that part down. Last times last, a negative times a negative is a positive. Square root of 2 times the square root of 2 is the square root of 4, which is 2. Well, look at that. That's going to work out really nice. -1 plus 2 is 1. -5 plus 1 is -4. And then you maybe don't have to do the workspace here and you just distribute the -4. I'm going to put it over here since distance learners might be using this. So we'll get -4 plus 4 square roots of 2, which isn't extremely pleasant, but at least we had one here that wasn't bad. And 8 minus 4 is 4. And now, find some work room again. We have to take the quantity 1 minus the square root of 2 times the quantity 4 plus 4 square roots of 2. Using FOIL, first times first is 4. And now remembering what happened last time and thinking ahead that this should just come out to -4 if this is going to work. The outside times outside plus inside times inside should cancel out. So let's see. 4 square roots of 2, -4 square roots of 2. It does. Last times last will be -4, and then we'll have the square root of 2 times the square root of 2, which is the square root of 4, which is 2. And it'll be 4 minus 8. Woohoo! Yes! -4. That was the first time through with the irrational. That tells us the second time through, gonna be easier. Again, you probably won't need all the workspace and everything, but we need to use that conjugate to 1 minus the square root of 2, which is 1 plus the square root of 2. Bring down your 1, multiply. Well, hey, look at that. Those are going to cancel out. I'm going to get 0. I like multiplying by 0. Gives me 0. -4 plus 0 is -4. Distribute the -4. -4 minus 4 square roots of 2. Yes. Then we'll get a 0. So we had 2 zeros, even though they only gave us 1, thinking logically, hey, the minus is there, the plus has to be there. It's conjugate. And now these last two, remainder constant x squared. Oh, well, that's a nice one. That's a difference of 2 squares if we factor it. X plus 2 and x minus 2 will multiply together to x squared minus 4. And that means our last zeros are going to be -2 and 2. And then I think, best practice, how did they give this to me? And I noticed that this had that f of notation again. So here's theirs. Now, not only did we reason logically to the 1 plus the square root of 2, but we also verified it synthetically. That's huge. We have to verify that. And then f of -2 equals 0, and f of 2 equals 0. And it was a degree 4 polynomial, so we had all of these. Now, as we're going through this, I hope you were thinking to yourself, why didn't Cedarholm write down all the list of possibles like we've had to do before? Well, that was because they gave us those starter problems, and so we didn't need to do that. If we go in and we have no idea what any of our zeros would be, and it's not a quadratic, we've got to find them somehow. So if they don't give them to us, then we've got to grab the graphing calculator. So this one says calculator permitted for a reason. It says if p of x equals 8x to the 5th minus 14x to the 4th minus 22x to the 3rd plus 57x squared minus 35x plus 6, list all the possible rational zeros, then find the simplified exact real zeros, use the calculator to help you find rational roots, and use, oh, no. And use, let's put CTS right there, completing the square. All right, so let's see, possibles. Well, first I'm thinking it's a degree 5. And that gets me thinking that I need to find 3 zeros to work this down to a quadratic. Then I'll be able to find the last 2. But I don't know any of them yet, so I need all the factors of the constant in back, divided by all the factors of the leading coefficient. So we'd have quite a long list of possibles here. 1 over 1 would be 1, 1 over 2 would be 1/2, 1/4, 1/8, etc. If the problem on the test said, and it does here, list all the possible rational zeros, we do have to stop and write them all out. So 1 over 1 is 1, 1 over 2 plus or minus 1/2, 1 over 4 plus or minus 1/4, 1 over 8 plus or minus 1/8. Now we go back with the 2 on the top. 2 over 1 is 2. 2 over 2 is 1, already on our list. 2 over 4 is 1/2, already on our list. 2 over 8 is 1/4, already on our list. We don't write them down twice. Then we need 3 over 1, 3 over 2, 3 over 4, that one's not there yet. And, oh, it flipped down here. 3 over 8. Up to the top for the 6. 6 over 1, not on our list yet. 6 over 2 is 3, already in our list. 6 over 4 is 3/2, already on our list. And 6 over 8 is going to be 3/4, already on our list. So we are really fortunate to have a graphing calculator. Otherwise, like I said, back in the day when we did these, we would have to do synthetic with 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 of these, just hoping that we would find one early on. So we're not going to do any hoping. We're going to use that graphing calculator, and we're going to see if we can find at least 3 nice ones in this, because we need 5 altogether. All right, so you guys go ahead and punch it in while I get mine set up here. Once you have it in, we're hoping for 3 nice ones. I guess my first place to go would be the table. You know, I'd be hoping that there's some obvious zeros in the table. Beautiful. -2 and 1. So there's a couple of them. We know -2 and 1 are going to work. Now, that's not enough, because I need 3. So I'm going to do second trace number 2 and take a peek at the other zeros. 0.292893322. I don't know that one. That is not a decimal that I know is a common fraction. So, second trace, number 2. Let me try the next one. This one's a little harder, and you could always do zoom box and get in a little closer on this one. I'm just going to try to be above and below. Oh, we know that one. 0.75, that's 3/4. So I'm not even going to try the other one. We had 2 of them already. -2 and 1. And then we just added 3/4 to that list. But we have to verify them. You know, might have punched something in wrong. So why doesn't everybody just go ahead and do your synthetic, and let's do them in this order. So we're all doing the same thing. That way, if somebody messes up, we can see exactly where it was. How we doing? Everybody get a chance to check there? Does anybody need more time? Unmute and let me know.
I need a bit more time.
Okay. Does anybody still need more time? Don't be afraid to say something.
Still a little bit, yes.
Okay, I'm going to grab a tissue. Let me talk about that last one then. Ignore me if you're not done. Just ignore me. Remember that multiplying 3/4 times 8 is multiplying 3/4 times 8 over 1. So really you just have to multiply the numerators and then divide. So 8 times 3 is 24, and 24 divided by 4 would give you 6. Then you do your addition, you get negative 16. Negative 16 times 3 is negative 48. Negative 48 divided by 4 is negative 12. Do your addition and you get 4. 4 times 3 is 12. 12 divided by 4 is 3. You put the 3 in there, and away you go. Anybody still need more time? Well, and let's finish this little doggy up. Remainder constant x squared. Greatest common monomial factor. We can take a 4 out of this. So now we have 2x squared minus 4x plus 1. And we have to find the zeros. And here's what I know. That is not going to be factorable. How do I know that? Because I saw that decimal before, 0.29, blah, 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 and I didn't recognize it. If I don't recognize it, then there's no way that this is going to be factorable. Factoring only gives us rational zeros. So I can divide both sides by 4, since that's not going to affect my answer at all, or the number of answers. And then I need to complete the square. So I'm going to move the 1 over first, and then I have to divide both sides by 2. And that's because we know that we can only complete the square when there is a 1 in the A position. And our A position is a 2 right now. All right, we need a b over 2 squared, so negative 2 over 2 is negative 1. Squared is 1. Nice little number to work with. So this is now the quantity x minus 1 squared, and negative 1/2 plus 1 is 1/2. And now that we have something squared, we can go ahead and take the square root of both sides. And then I need to rationalize this one, and that's because the square root of 1 is 1. So we'll have 1 over the square root of 2, but I know I can't leave that because that has a radical in the bottom. So I'm going to have to multiply my numerator and denominator by the square root of 2 and get the square root of 2 over 2. And then I can add 1 to both sides. Now that's why we didn't recognize 0.29 blah blah blah, because it was 1 plus the square root of 2 over 2, and the other one was 1 minus the square root of 2 over 2. In fact, that's the one that we saw first, 1 minus the square root of 2 over 2. We don't work with that every day. We don't recognize that when we see it as a decimal. So now, this one just said find all the zeros. So you could write this one with the f of notation if you want to, or you could write them as ordered pairs. It's not going to make any difference. So we originally had our negative 2, our 1, and our 3/4. And we added this kind of nasty irrational 0 here. And we recognize that that counts for 2. And like I said, you can just write it as 1 with the plus or minus in there. So 2, 3, 4, 5, got them all. Our inventory is done. So at this point, you start thinking, well, haven't we seen, all the different forms of zeros that we could have for polynomials? And of course, we didn't do imaginary yet, so that's what the next section is about. But we're not quite finished. And this says find the given value of k so that the given divisor d of x is a factor of p of x. Now, what's supposed to really catch me here is this. It's a factor. So that means it goes in evenly. That means it has a remainder of 0. Hey, wait a second. We had something called the remainder theorem in this section. And it said, if we want to just see that our remainder is 0, we should take our divisor in that x minus a form, figure out what a is, substitute it in here, and we'll get 0. Well, that's what we need to do. So a, in this case, is a negative 1. So wherever I see an x in this polynomial, I should be putting negative 1. And I know what the answer should be. It better be equal to 0, because otherwise it's not a factor. It has to have a remainder of 0. So negative 1 to the 4th is 1. 3 times 1 is 3. Negative 1 squared is 1, so that'll be plus a k. Negative 2 times negative 1 is plus 2, plus 1 equals 0. Well, that's k plus 6. And we would subtract 6 from both sides. The only way this is going to work so that it will be a factor is if k is negative 6. All right, now I want you to use that same thinking for b. I'm not going to say my steps as I go through it. I want you to try it, and then I'll have my answer up here so you can take a peek. Anybody need more time? The whole point was we know that A would be 2. And that means if we put a 2 in for all of the x's, we should get a remainder of 0. And we solve it for that. Now, after all of the difficult, and I don't know that they were definitely step intensive today. I don't know that they were difficult, the problems that we did. This sometimes seems way too easy, and then we tend to forget it. So if I were you, I would put a big star on it because this is a problem that we could put on the test just as a kind of a little filler piece. These don't take a lot of steps. They don't take a lot of thinking as you go through it. But it would be a good thing just to have one on there to remind everybody, hey, the remainder theorem is pretty huge. You know, if you put your factor in, you should get a 0 for a remainder. All right. That finally completes section 2.4. So, like I said yesterday, this one you should have been able to turn in the 2.4 day 1, but now you'll, if you didn't already, I know a lot of you already did, you completed the 2.4 day 2 and had that in there too. But only the 2 assignments over the 3 days that we covered this.